So, welcome back, everybody. So last time we did a little mucking around with our first entity, and today we're gonna actually create ourselves a manager class. And this manager class is gonna be responsible for handling all game entities and doing all the functionality. So let's start out by creating a new project. Blah blah blah, that's good, we'll go with that. Then what I'm going to do is I'm going to do the usual. I'm going to take this as all my code. I'm going to copy it. Actually, I don't want to copy it. I just want to drag it in. There we go. And then I'm going to want to take my images, Mario and his background, and then I'm going to drag it in there. So there we go. So there's all the files we had from before. Should be no compile errors, but we still have a blue screen because my game shell is lacking in content of anything. So let's create our manager class. We're going to actually have a few managers, and the first major one is an entity manager. But we're going to create an abstract manager class. And how you create an abstract manager class is you select a class from code files, and we're going to call it manager. It is going to be in the class. It's going to be in the namespace of managers, and it is going to be public. Actually, no, it's going to be internal, because I only want anything in the manager namespace to see it. And it is also going to be abstract. So remember, abstract classes cannot be instantiated. That means we'll never have a class manager, which is fine by me because I don't want a class manager. Now what we're going to do is we're going to have a few functions in this class. We're going to have a public, abstract, load all content, and we're going to do copy all our X and A stuff over. Sorry, let me zoom in here. There we go. So internal means it's only available in anything that has anything that's inside the namespace managers, as well as abstract, meaning this can never be instantiated. And we notice we have the word abstract here. Abstract means, remember the other day we talked about interfaces and how you didn't put any code implementation? Abstract classes are a lot the same as well. We don't have to do code implementation as well. Oh, I need a return type. If you declare a method abstract, it means you cannot have a body, meaning you cannot have this with code in the middle. It is basically just the signature. So any class that's going to inherit from manager has to implement this function. And it is going to take a content manager, and the variable is going to be content manager. So now any class that inherits is going to have to take this abstract one. Like I said, not putting abstract, if we take the abstract out, is going to now complain. You hover over it, must declare a body. So if you take abstract out, you have to do this. There's another one called where's my hand? Virtual, which is like abstract, except it's allowed to have a body. And what I mean by it's like abstract is this can be overridden, and we'll see this in a moment. But I don't actually want there to be a method called load content in the manager class. I just want to define the method name. So anybody that inherits from this class has to implement this function. I also want them to also have a public abstract void update all entities. Let's go take in game time. So yet again, there is no body. This is perfectly legal because abstract classes can't be implemented, so it's not going to let you be able to access these methods unless you inherit. And the third one is going to be public abstract. Guess what? Void draw all entities. And then we'll just do that. And it's going to take a game time and sprite batch. So that's our abstract class. There we go, all's running smooth. You don't have to actually do that all the time. You can just go to build and then F6, and that will give you whether or not you have mistakes or anything. So yeah, there we go. So these classes are not, these methods do not actually exist. It's really just saying, okay, you inherit from me, you must do this work. So it's like a manager. It's literally like a manager. Think of it as a manager saying, all right, I don't feel like doing anything, so you do this, is what happens. So who does he tell to do this? He tells a manager. And we're going to create a new one called entity manager. I think that's what it says there. We're going to put in our XNA information, header files. Change this to managers. I think I had a little too many. Did I have a few extra? I don't know. And it's going to be a public because people outside of this class are going to need to see it. And we're going to inherit from manager. There we go. So if we build this, is it F6? We're going to get a bit of an error here. Yeah, okay, so I guess it has to actually be the same. So I guess it can't be internal, so we'll make it public. And we'll build it again. Can't tell if I hit F5, but we double click. It's telling us that we have not implemented update, load, and draw. So we should do that. So let us bring this back down. We are going to do public override. We want to override load content. Public override void update. And notice that it fills it in for us. As soon as we type in the word override, it gives us a bunch of functions that we want to override. Now remember, these three belong to object, but these three are the ones that we have declared abstract here, and we're going to override them. If you take this out, the compiler will complain. Hides internal member override, hides internal member manager update all entities. To make the current member override the implementation, add the override keyword. So that's the mistake you'll get. Basically what it's saying is you're not actually overriding. So there we go. We've override these three statements. Let me zoom out a bit here. And I believe that. Yep, that works. It's hard to see which F keys I'm pressing. So there we have our we have our entity manager. So this one's going to be responsible for updating every single entity in the game. So let's try loading. How do we load? Or first of all, let's have a field to where we're going to send, where we're going to hold all our entities. And this field is actually a field built into the C# framework, and it's called a list. And the list is a generic type, so we use these angle brackets and we declare what we're going to be holding. And we're going to be holding entities. So we have to declare using entities. There we go. We're going to want to hold not just any entity, we're going to want to hold game entity. There we go. That is what we're going to want to hold in here. So anything that could be displayed to the screen is what we're going to be holding in here, and that's all game entities. Go back to game entity. This thing is going to be drawn. Pretty cool, huh? Not really. It will be pretty cool in a moment. We're going to call this the entity list. So here's our object, which is an entity list. Boom, there it is. This will contain all our game entities, such as the player, the enemies, the sprites for the backgrounds, and everything. So there's our list. Pretty fancy and all that. We're going to want to go through our list, and we are going to want to do certain things. So how do we go through our list? We go like this. For, so we create a for loop. First thing is we define an iterator, which is I, int I. We set it to 0. Then we set our condition while I is less than entity list. Now how do we get the size of entity list? We hit dot, we can access count. Yeah, count, which gives the number of elements in the list. There's another one here. Dot length, no, C. Let's count, but there's another one that actually gives the number of space available. That one you have to watch out for because it's not actually the number of elements. Count will actually give you how many actual elements that are accessible in the list. And then we have to increment. There we go. So how do we load content in our manager? Simple. Entity list. Use the square brackets, dot I to get the index. Dot load content. We're going to pass in content manager. So there we go. What this is going to go through is it's going to go through each list. So if we have 5 entities in this list, it's going to go 5 times through each one. So it's going to start at 0, 1, 2, 3, 4, 5, and update everything for us. Is that not cool or what? Awesome, eh? So how do you think we're going to do update all entities? Quite simple, quite simple. The exact same thing. So we do our for loop. We do our iterator. We do int I equals 0, not minus 0, equals 0. Our condition statement, while I less than entity list dot count I plus plus. So how do we get our entity list again? Or sorry, how do we access the entity in the list? Well, just go like this, square brackets, dot. We don't want to load content in this one, we want to update. There we go. Update, and we're going to pass game time. So now this is going to go through all 5 elements and update the game time. And pretty much it's the exact same thing for draw all entities. Pretty simple, hey? The only difference is one draw. and we want to pass in sprite batch. So that's going to go through, and that's going to draw all our entities to the screen. So there's a few things extra we're missing here. First off, the constructor. And the constructor is, well, it's not public. The constructor is something we'll talk later, but for now it's going to be public. Entity manager. Did I spell that right? No, I didn't. An extra I and one less T. And did I? T, yeah, okay. Sorry, it's really screwy with the eyes when I see that. And in our entity manager, we're going to want to create the new. Oh man, I spelled entity list wrong. Wow, that's pretty horrible. You could just go up and change, but you can actually just find and replace all in a file, but I don't have that much there. Entity list is going to become a new list that's going to take in game entities. So this list will only take in game entities. You can have lists that take in other specific entities, which we'll see later. And we need two functions to be able to access this stuff. So the first one is public void add entity. It's going to take in a game entity ent, and we're going to add it to the list. So how do we add it to the list? And I spelled entity wrong. Well, actually, first we're going to want to actually define these in here. We're going to want to have a public abstract void add entity I have to use the using statement to tell it what an entity. What an entity is. Perfect. Game entity. There we go. And we're also going to want a public abstract game entity get entity. Int I. And finally a public abstract game entity remove entity game entity T. Actually, I don't want this to be an I. I want this to be game entity. So these three methods we're going to have in there. What's this complain about? Okay. Perfect. Public, we're going to have to override. Override. Get entities. Public override remove entities. So first, how do we add? Adding's easy. Simply add dot. Well, what do you know? First one. ENT. This will add an entity to the list. If ENT is null, it will not add it to the list. And then let's do the list, entity.list. It's not actually get, it's something else. Yeah, we're gonna have to actually make our own get. So we're gonna do a for loop, starting off with our iterator, I equals 0. I think there is actually, a the ability to look for it, but I don't remember what it is. Entity list dot count. Then we're gonna increment. What we're going to do is we're going to check each entity list I dot equals. This is the method that we override from object. So if we pass in ENT, if we go back into here and jump to definition, this is the one that we overwrote. That is going to check if the name is equal. So the object is going to come in, it's going to be entity, type base game entity, which is going to be because game entity inherits from base game entity. And it's going to check this one, and it is going to see if the ID and the name are equal. If they are equal, it is then going to spit it out. So we're going to say if this returns true, return return entity I. So it's going to return this. Otherwise, if we cannot find it, return null. If it's not in there, don't return anything. Null is a valid point. Now null is another object, so you can do this. So it's going to loop through the list. If it finds it in the list, the first count of it, which it should only find 1 because the ID is only 1, return it. We probably won't use it that much. It's just here more for necessity. And finally, remove. Remove is a lot simpler. Entity list dot remove. And remove is going to remove ENT. It's basically going to find the same object as ENT and remove it. And yeah, we don't want to void. We don't want to return anything. Sorry, sometimes you're going to do this where you're going to change your code to match what you need it to match. So we did F6. Did I hit F6? I think so. That's why I hit F5. I can never tell if I hit F6 or not. Alright. So that's cool, eh? So there's our entity manager. That's going to populate our manager with all these little things, and this is going to do all that we need it to do. So let's go to our main program here. And we are going to create, first we're going to put in using entities, using managers, and we are going to create our entity manager. We'll call it manager. And then we're going to go down to our initialize, and we're going to create it. Manager equals new entity manager. And we're going to populate our manager. We're going to add our first object, which is going to be game entity. It's going to be Mario. It's going to be the first one. Mario equals new game entity. We're going to pass in Mario as his name. And that's all we have. We're going to take Mario and we're going to set his asset name equals Mario. We're going to take Mario and set his position to equal new vector 2 150. And I don't want it to be 150, 150. And now after I've created Mario, I'm going to want him to add it to our list. So let's do manager dot add entity, and we're going to add Mario. There's Mario. Now he's added to our entity list. So let's go down to load content here. And the first thing we're going to do is we're going to call manager dot load content. This will now load all entities. So if there are more entities like Luigi or Goomba and stuff like that, it will load it. I don't care about unload. We're also going to update all entities. So we're going to call manager.update all entities, passing in the game time. And then same with our drawer. Well, we got to do the begin and end. So sprite batch.begin, sprite batch.end, and we're just going to call manager.draw all entities, passing in game time as sprite batch. So let's run this and see what we got. Hopefully, if we're lucky, there's our little Mario, which I haven't set his scaling or anything. Alright, so let's just reset his Mario dot sprite dot scale equals 0.55f, and we'll make his origin equal new vector 2 We're going to take in Mario dot sprite dot width is sprite dot texture dot width divided by 2. Sorry, you probably can barely see this. Divided by 2, and Mario dot. There, I just have that do the texture. I don't have to do the sprite dot texture. Forgot that I did a layout. Dot height divided by 2. Oh, what did I do? Oh, silly me. I made a grand old mistake. And we're gonna just kind of take that out. We'll leave the origin out for now. And this is gonna probably crash with the sprite as well. Oh no, it worked with the scale. Oh, because the scale is a number, it's not an actual texture, so that's fine. Whee! So there's Mario. So what's cool? Why is that important? Because check this out. What if I do something like, say, this? I don't know. What am I doing? What do I want to do here? So Mario I'm gonna do this, put a comma there. Now because it's a, since the instance is within scope, it's a, not a member variable, but a scope local variable. We have to set it to null. And then we're gonna say Mario equals null, and we're gonna do a for loop again. A lot of for loops. I less than 5, we'll say. I plus plus. And we'll put all this code into brackets. And what we're going to do is we're going to actually multiply the position by 20 by the index of I. And we're going to do this 5 times. Oh my freaking god, what, whoa, that's the scale. It's the flying of Marios. Multiply by, oops, multiply by 20, and then 2 multiply. That should bring them down a bit more. It brought them down, but not enough. There we go. Whee! So we now have 5 Marios, 5 entities within that Mario, each with unique IDs, flying around. Is that not nauseating or what? Pretty cool, huh? Not bad at all. So there we go. There's our game manager, and this will actually pretty much cover, as long as you continually add objects to this manager, you never have to change any of the load, update, or draw. And that's what the whole point of our manager. It takes care of all that crap for you. So all you have to do is add crap to it. So there we go. And so that should be it for today. In the next episode, we'll improve on this entity manager to add a bit more functionality to it, to do other stuff such as get certain types of stuff. We're going to talk about indices and indices, as well as the design pattern called singleton, and that will come important in the next episode. So folks, thank you for watching, and once again, Mario's going to fly across the screen. Oh my god, with his 5 twins. Bye now.